Welcome. I want to talk about growing and evolving your APIs with Go. I purposely made this so that it can be translated to other languages other than Go. So I'm not using Go return. Bear with me. Go return error. So what's wrong with this code? We just want to add two numbers and true enough, it runs. But shouldn't we use functions instead? So here I've written a function and it still runs. Good. But now, because function is used all the time, shouldn't the sum function be in a library? So let's write a library called the arithmetic package. Well, libraries in Go are called packages. But let's first run the code. Before we run the code, here is the package, the arithmetic package, and this is how we call the arithmetic package. It's arith dot the function name. So let's run this code. And yes, it runs. No surprise there. So this is how we write packages or libraries in Go. We start off by saying this belongs to the arithmetic package, and the sum of two integers is this. Note that in Go, exported functions start with an uppercase character, and you should always document exported or public functions. That's why sum has a comment here, and this will be shown in the Go doc or Go documentation tool when we run it. So the contract here is we call sum with two integers, and we expect to get an integer in return. Now, as time moves on, requirements evolve, and we now need to sum three numbers. How do we do that? I used to code in Java, and Java has what I thought at that time was a cool thing, function overloading. You could actually have a sum with two integers and a sum with three integers without changing the function name. Scary, isn't it? It recognizes the function signature and it knows how to call the correct function. Do not do this. It works in Java, you can see it works in Java, but Go absolutely does not allow this. Why? Simply because sum is a contract which accepts two integer parameters. This contract is broken if you try to call it with three integer parameters. So that begs the question, how do we evolve the sum API in Go? We could, of course, make a new contract, give it a new name, sum3. So let's add two numbers. We have the normal sum here, and when we add three numbers, sum3. And it runs, I'm sure. Sum3 runs. We can add three numbers. No surprise. But what is wrong with making a new contract? You can argue sum3 works just fine. But how about sum4 to add four numbers? And how about sum three integers and a float? And as you can imagine, as your needs grow, as the business evolves, you will get an explosion of some XXX functions and an explosion of interfaces or contracts to maintain. If this was a remote procedure call, if sum was a REST API delivered over HTTP JSON, you would have an explosion of endpoints to maintain. Obviously, not sustainable. How about writing some GP, a general purpose sum function like this? That's a rough idea. Let's work it through. We pass a parameter x, which is of type something, and it returns an integer. Where something, it's any one thing, can be a structure like this. So I create a new type. This is how you create types in Go. Type three nums. It consists of three numbers, A, B, and C. And we can implement some GP for general purpose as like this. But then look at it for a while, it gets us nowhere. How about sum GP x 4 nums? It doesn't work. Or does it? It can work if we remove Go's safety belt. Now Go is a fantastic language because it's got strong type checking. Interface open brace, close brace, it's pronounced empty interface, removes that type checking. It says you can put anything you want in there, any one thing you want in there. So we can define some GP x of type empty interface and returns an integer. So now you can call some GP with 3 nums, 4 nums, any type you want to define. However, it is now the maintainer of some GP's responsibility to check that it can actually handle all the types that are passed to it. This is how it looks like implemented in Go. 3 nums are defined here, 4 nums are defined here, and some GP is defined here. This is called a type case or type switch statement. This construct over here, x.type, will determine what type x is and assign it to the variable v. So if v is 3 nums, we know to add a, b, and c. If v is 4 nums, we know how to add a, b, c, and d. If it is neither 3 nums or 4 nums and is something that some GP doesn't know about, it dies. Or you can return a bad error value, but this is bad. In Go, we actually return errors. But in other languages, you can't return multiple items. In Go, you can. This actually seeds the idea behind schema versioning. What is a schema? It's just a fancy word for describing the thing you pass to the API. That thing could be 3 nums, and the schema API for 3 nums, the schema for 3 nums is just this, and the schema for 4 nums is just that. So we can define the schema for a generic thing to be this. It's just another Go type. It consists of 2 public fields. Now public fields start with a capital letter, version, which is an integer, version 1, 2, 3, 4, and x, where x can be any one thing, the empty interface. So generic thing version 1, here's the idea behind schema versioning. Generic thing version 1 can contain x with 3 numbers as type 3 nums, and version 2 can have x with type 4 nums. Now there's no free lunch. The maintainer of generic thing now has to document and publish what can x be, what are the acceptable types for x. And the maintainer for the some generic function, which now accepts one thing, y, as a generic thing, has to know how to track y version and yx, which is the empty interface that is passed in. How does the arithmetic package look like now with some generic? So I've defined generic thing here, version, x, both public elements. And here is some generic taking one parameter, one argument, which is the generic thing. If the version is 1, we check, the compiler must check that it is actually a 3 nums, otherwise it will panic and fail. But if it is actually a 3 nums, we just return a plus b plus c. And if the version is 2, we check and assert that the thing that is passed in is actually a 4 nums. And then we return the sum of a, b, c, d. And as usual, if we pass in something, some version that is unknown to some generic, it dies. And we should actually return a go error here. How do we use it? This is the main function, making use of sum generic. Print three numbers here, arithmetic sum generic. Well, we're calling sum generic from the arithmetic package. And we're using a generic thing from the arithmetic package. Version 1, pass in the three nums. Version 2, pass in a four nums. Let's go and run it and see that it works. It better work, otherwise I'll be terribly embarrassed. So I'm running sum generic main. Hey, it works. Thank goodness. So if you want the code to both the presentation and the code snippets and the examples I've given, it's here in my GitHub page. Thank you. I'm Siu Yin and I work for Zendit.